Question D says, show that the root of 2x squared plus open bracket 1 minus 2m close bracket multiplied by x minus m equals to 0 will be rational and non-equal. To do that, we're going to use the discriminant. We have to show that the discriminant is greater than 0 for what? For non-equal and for non-equal roots. And also we have to show that the discriminant is a square, a perfect square. We have to show that the discriminant is a perfect square. So we are going to say b squared minus 4ac. This one, our b here is 1 minus 2m square minus 4, our a 2, our c minus m. So here we have 1 minus 4m plus 4m square minus, and the minus giving us a positive 8m. Therefore this is giving us 4m square minus, and giving us a minus 4m plus 8m, giving us a positive 4m plus what? Plus 1. So we can simply factorize this into 2m plus 1 square. So this, therefore our discriminant is greater than 0. Even our discriminant is equal to a perfect square. That's all we can say, perfect square. Our answers here. To explain this a little bit better, we know that our m is an element of integers, so we can see that for every, even if we can subtract a negative numbers of our integers, our discriminant there will be positive always. Therefore will always be equals to, it will always be greater than 0. And we can see that here this is a perfect square, therefore we have a square, therefore our answer. Question E says, determine the nature of the roots of b square x square plus x square plus 2 plus bx equals to 0. So we are going to first arrange this, giving out with x square b square plus 1 plus bx plus 2, even in this form where we have b square plus 1 x square plus bx plus 2 equal to 0. Therefore we have our a, our b, and our c. So we are asked to determine the nature of the nature of roots of this equation. We're going to use the discriminant, which is b square minus 4 ac. Our b is b then square for our a, b square plus 1, our c 2. Therefore we have b square minus, first we're going to multiply using this one first. We have 4b square plus 4 multiplied by 2. We have b square minus now multiplying the minus, we have minus 4b or minus 8 p square. Now the minus 8. Therefore we have minus 7 p square and minus 8. So we can see that our discriminant here, even no matter no matter what number we substitute for p, it will always be a negative number, since our constant are negative here, and the square will not influence our value here, or our value here. So therefore our discriminant is less than 0. Therefore we want to say the roots are non-real.